So first of all, hello to everyone. My name is Diego. I'm sorry that I couldn't join you, but still, I would like to talk to you a little bit about my experience creating the plugin. I work in the Sadewasser Group at INL. I'm doing my PhD. So first, I would like to introduce you. My group is the Sadewasser Research Group. Before we were called Laboratory of Nanostructured Solar Cells. We work in Braga at INL in Portugal. And we have two different lines. We work with material development for energy solutions, either in batteries or in photovoltaics. And we put a lot of effort on the characterization. We do a structural, chemical, electrical, optical, and nanoscale resolution characterization. So we have a strong thing, a strong focus on the characterization for these two specific activities. So first, regarding the photovoltaic, we focus on thin film solar cell devices, where we have devices that look like this, that are like really thin, with different layers. We have a lot of different deposition techniques. We have this homemade deposition technique where we can put a substrate and take out a solar cell by making a lot of different steps and layers and transfer the sample across, where we have a lot of things. We also do it in the solution way. So, well, like for example, chemical bond deposition, spin coating, etc. And we do applications like this one where we can like have every line of this is a solar cell. So we can have like transparent light, so semi-transparent solar cells, but so the light can go through, but we can get energy out of it. We also do a lot of work on SPM. This example here, for example, is KPFM done on top of an absorber material, so a material that can work for a solar cell, and we can see how the material interacts with light when we are while measuring like at the nanoscale. Here we are around like 5 micrometers. We also see different effects on the efficiency of the solar cell when we do different processes, when we do annealing, and when we do all of that. So in general, we work on these kind of things for the solar cells. Regarding the batteries, we are focusing on solid-state thin-film batteries. So we have a whole pipe, pilot line of connected glove boxes. And inside the glove boxes, you have different physical vapor deposition machines. So we have some sputtering machines, we have some atomic layer deposition machines, we have some evaporators, and all of them are connected in an argon-based glove box. So that way we can have the whole battery without any problem, and even the characterization can be done inside the glove box. In this case, we have machines. We have samples that look like this, where we have the substrates, the cathode, the electrolyte, and the anode, everything being solid state, which is useful for applications in the medical realm, mostly in the medical realm. We have samples that look like this, either cone cells or pouch cells for testing, but at the end, the final application, we will have a smaller device that will produce a small amount of energy. We measure capacitance, or we go to the microscope and we measure the layer devices, or we go to the AFM and we measure furthermore properties, like for example, this is nanocurrent before cycling and after cycling to understand what are the changes within the device. In these two applications, we have a lot of things in common. If we see both things next to each other, we have a set of layers and we have charges moving across the layers. So our common challenges are mostly, and the things that we discuss the most is like thin film deposition, how we form this interface and how we can change this interface to make it better, and how in this interface we have the charge transport between the different, the different electrodes at the end. So with this in mind, you will guess that we will have a lot of information and going like from XRD data, AFM data, electronic characterization, etc., etc., etc. And we normally do this by having a logbook, or we do a lot of graphs in Origin. We put things in Excel, we put things in PowerPoint, and everyone more or less have their own way. So that way, that's why during my PhD, one part of it is to create this plugin, which is the plugin that I call NOMAD INL base, and to put the thing in the NOMAD Oasis. Of course, I use a lot of help with cloud because it helps a lot to actually create the schemas and to speed up all the process. Because even though I don't know that much about programming, but I know a little bit, but still getting to use to NOMAD and everything, it requires a lot of big effort. So I did that effort when cloud was not available, but now that it's available, everything goes really faster and smoother. So I would like to talk a little bit about the plugin. So we first define some entities. We have some samples and equipment. The samples normally is looks like this. So we have a substrate and we have a lot of thin films on top of it. So we have an INL thin film stack, and it's composed by an INL thin film and by a substrate, following the same thing that we have in material processing. And these have things that name, where is the sample, how is the status of the sample, because sometimes we cut samples and we do different processing, what is the geometry and the normal things. And from the other side, we have all the equipment. So in the equipment, we have the sputtering target, which is the source where we get the material out for making the thin films, or we have normal instruments like tube furnaces, spin coaters, etc. And that way we can track both things, the deposition track and how we use the instruments. So in this case, we have a calibration history of the different targets. We can track the energy because based on the energy, we can decide when do we have to calibrate target. We can have an inventory of the target so we can know where to buy or not. And we can even have a maintenance records of all the different instruments. So that way we can actually have an easy way to access what has been done to the different machines. A lot of the machines are more homemade, so it's really important to have an easy way to record this maintenance process because we are the ones that we do all of that. Now that we have the entities set up, we do activities with the entities. Most of the activities are depositions. We deposit a film on top of each other, but we also need to clean substrates, cut some material, activate the surface. So we had to define these activities. We define these activities based on two different things. So the first one is more manual activities, so where we don't have a log file and it's not really automated. So it's basically we do it with our hand. It's including cleaning, deposition. Most of our solar cells, because we did a homemade machine, doesn't have any kind of recipe or any kind of log file. So we have to set up and write all the numbers. So this makes more complicated to actually put everything in an electronic laboratory notebook. So that's why we use recipes, where we have a recipe where all the parameters are more or less the same, stay the same. And then we just add the specific numbers that change for each deposition or for each cleaning or for each whatever process we are doing. This way we speed up also the user process, which is a huge thing, a huge problem, to actually start using the NOMAD for the users. We also have other processes that they do have a log file. So this one was very simple and straightforward, where we create a parsing directly from the ELN. We create a parsing directly from the log file to a ELN that create graphs and everything. This includes the E-beam deposition that we have that is called this meteor deposition, or everything that inside the batteries, they already, all the machines are already have integrated the login of the thing. So in this way, we can already put everything inside NOMAD and everything works without any problem. Later, we have a lot of characterization. As I mentioned, we do electron microscopy, force atomic microscopy, XRD, spectroscopy, impedance, electrochemical impedance spectroscopy, etc., etc., etc. And now everything you just put it on top of the NOMAD, and that creates the XRD spectra or the ACE spectra, the XRD pattern on the ACE spectra, the AFM images, or the EQE spectra, which is something specific for the solar cells, with all the metadata that comes from the raw file. So we just put the raw file on top. Right now we have around 14 characterization techniques where you only have to upload, and then you can link directly to the sample. So that way you can have all the processing and all the characterization linked together through the sample. All of that was complicated for myself to do, but I had a lot of help from the Copilot chatbot. And I would like to show you what kind of things we can do with it. So, for example, we can create new schemas. This case, we were doing, we were adding some specific step that is a salinization process, and I put all the different things that we do for the salinization process, or even the papers, and that way it was able to do the schema, or for example, developing the test based on NOMAD measurements. I want to do the test for this plugin. Can you, based on the things on NOMAD measurements, create a new parsers for characterization? For example, in this case, I want you to use these two packages, and this is examples of the types of files that you will get, and I will have to have the same idea of characterization that I have been doing before, so that way everything falls to create documentation. Creating the documentation sometimes is easy, but it requires a lot of time. So it really helps because it understands everything very fast. And like keep updating the documentation. It's really useful. For example, I had some users that create some files telling me, oh, this works, this doesn't work that well, this graph doesn't make that more sense, because sometimes it's really hard to understand what is better for the users to have in the front page of the sample or of their processing. So I just give it the file that my colleagues give me, and he helped me to it helped me to implement these feedback users. Or for example, with AFM data, I was really like lost because of the way that the raw data is processed. And by giving the raw data and explaining some specific plugins, it was able to create the parsing already and the ELN for the AFM data. So with this in mind, I would like to like make it a live session, and I will try to create a specific schema based on an endothermal thin film deposition, based on an article that I would like to copy. So with that, I will stop sharing this and I will start sharing my screen. So now you should be able to see my screen. Yeah. So this is the paper that I would like to copy. I have it here. Can I go to the link? Why I cannot go to the link? Okay, I will just look for it. Yes. So what I normally do is I take the paper that I want to copy and I ask Gemini that he can do uh, the extract to extract the part that I really want to have. Oh my God, why he got like that? Okay. And he will look for the paper and give me the information that he believes is more important for making an ELN, which normally it makes sense what he says. Give all the different units and everything. So now I put it into my cloud and I will tell him. No, I don't want an image. I don't like that he copies image. And then what Gemini told me. And I put it in plan mode always, so that way he didn't go to Gemini. So that way I can like have more of a track. No, have more of a track of what he's actually doing. No, this always happens with live stuff. Things doesn't go that way. Okay, can I copy it now? Yes. Okay, and then he starts analyzing everything, and he knows my code, so he will try to copy exactly the things that I want for the code. So that way, I think it speed up a lot of the process. Of course, it's not magic, so it's not like everything that it suggests or it does, it's just directly working. But it speeds up the process like a lot. Like it makes a lot of things way easier. And if you sit down and understand what it's doing, it also you understand a lot of things and how things are working. So yeah, I mean, now it will search for things, it will read stuff. Sometimes it will ask questions and tell me, hey, do you think we should do this or do you think we should do that? What makes more sense for you? What doesn't make that much sense for you? And I hope in a while we can see what it's saying. It's processing there. So as a PhD student, I had a lot of things to think about, and managing the data was also an important part, but it was not like the main focus. So having this to actually speed up the process helped me a lot to put all of the things more easily in Nomad because it was my supervisor was really all the meetings was like, you need to start use everything in Nomad, and I was like, okay, I have to, but I have to develop the whole plugin before doing that, and I also have to do other stuff, so it was more complicated. But this really speed up my process in a lot. Like for actually working on the plugin together with Cloud, it got me like 2 months to have it in a really good shape, so my colleagues could start actually trying it. And it's always a feedback loop. They try something, you improve, and then they keep going. So yeah. So now it realized that the chemical bad deposition, which is a process that is very similar to the hydrothermal process, is the most close one. So that's why he's focusing now on that one to see if it makes sense. Now he's completely off because two furnace annealing is not that close to to an hydrothermal process. But let's see.
Diego, can you hear me?
Yes.
Maybe we can take questions in the meantime because we're kind of running out of time for the presentation slots. So while Paul is doing his job, we could like get some questions already from the
Sure,
audience.
sure, sure. If you want, while it thinks, we can get some questions.
Maybe I can start. Um, so I think your from my point of view, you're doing exactly the right thing to speed up the schema and plugin development into the AI tools. And I would recommend that this would be like what other people would also try out. Obviously, you need the manual labor there as well to make sure that everything is correct and you understand what has happened.
Yeah.
But what do you think, like from our code base or documentation, like does the AI agent always steer off because of certain reasons? Do you think we should improve the documentation and examples, or does the agent typically get it right
So
or wrong?
in my experience, it gets better with time. At the beginning, the agent was making a lot of small mistakes that you could see that there were mistakes. But it's good that you can keep like it's good that he's always well. It's not a he. It's good that he's always looking. He's always showing what he's thinking. So that way you can like already during the thinking and the analysis process, you can already direct it better. But it's something that is a trial and error. Like it really gets used to what the code should look like and what you like for the code to do.
Yeah. Okay. Let's maybe take a few other questions and we'll see what finishes. So, any other questions from the audience at this point?
I saw in your slides that you actually keep track of status of the equipment, and I assume the targets, for example. Can you tell me a little bit about the approach that you use to keep track of those status?
So basically, the idea is that every deposition is linked to the target because every deposition has the source linked to the target. So that way, if we go to the target page, we can have the reference of which depositions was done there. So before Nomad, we do that in Excel. So we were like logging every time we did a deposition. But now by making the deposition, the link is already done with the target, and then the target knows how many depositions and where when these depositions happen. So that way, for example, for the targets, we can keep track of how is it going. For the maintenance, it's just basically an ELN entry where we have maintenance records and we have like the different the date of and the person who did the maintenance and a description of what happened. So it's more of a keeping track way. It's not that systematized. It's not the data.
Take another question. Yeah, other questions?
I just have a comment actually about the, I mean, in terms of like using the AI tools, I think like, I mean, a tip or a best practice is also to point to the like other plugins and such, especially you can use the like distro dev for this, that you can grab other plugins and have them locally that you should point to, right? This will help the like sort of the keeping the like the best practices of the code in place that have been implemented manually in the past, right?
Yeah, I mean, there is not that you can start from zero. I think it's good that you start from something. So thank God the Nomad community existed, so we can already like make the same, continue the same things that manually people did already. So for example, a lot of the web deposition process, that is where I focus the most experimentally. It's based on some really good plugin that it was before. So I do a thing that we need a base, and that base has to be manual, and that based on that we can like keep using the AI, but it's not like just out of nowhere it can do everything. So yeah, for sure we need some manual work before.
And I think that's an important point that you should tell your agents to give the knowledge about the existing plugins, because it's very easy for the AI to reinvent the wheel always, and that's not what we want. That's not fair. So that's why you need to try to keep track that you give the agent enough information about already existing schemes.
Yeah. Yeah, at the end it's not something that is just by independent. It's not completely independent. You always have to like keep track of what is happening and what is not happening, because at the end the AI can hallucinate a lot.
So maybe you can wrap up the presentation. We'll then.
Yes, I will finish the presentation then, and then. So well, I got there, I show how we do it, and then the current challenges that I'm having right now is to actually make people use it, because it's hard to move people from where they were and how they used to do things and to actually use Nomad. So I have had a lot of problems actually pushing people to use it. Right now, I'm also moving into the analysis part. So I have the data more or less already in Notepad. I want to move to the analysis part. So I'm trying to use a lot of the plugin that already exists for the Nomad analysis, to use the things with the Voila or for the Jupyter, but still it's a working process. And this has to keep going. Like there is always new experiments, there is always new workflows, and there is always experimental things, and I have to keep up with whatever me or my colleagues work in the lab. So with that, I would like to thank you and thank the FCT, which is the scholarship that I got for doing my PhD. And thank you all for your attention.